Hi, everybody. Welcome back to the show. My name is Aleia. I am your resident technologist, scientist, roboticist. I try to do all of the things. If you're new to the show, this is Eve, Electric Vision Entertainment. And what we do here on this show is we talk about science, technology, we code things, we build things, we generally make things. I am your host once again, Aaliyah. If you don't know me, I am a senior studying data science at Make School, and I'm also a student ambassador, which is what led me to making this show. If you already know me, welcome back. So today, what we're going to do um, we just always try to do this show every week, and the holidays came. School was out. Everyone wanted to enjoy time with the family, get a little R&R, and so we decided to postpone the show out until life got back into the swing of things. So now we're back. However, we already had planned to do a snowman episode where we coded up a snowman just to practice learning a new language, a new style, just have a little more fun coding rather than always doing the mathematical part of things. So we didn't want to scrap it just because the holidays had passed. So we're going to do that today. And what we're gonna do is just like in most of the format for this show, I'll explain kind of the framework that we're using, the language that we're using, and then I'm gonna get into kind of what I've created so far, break it down, and that way we can see how different things interact, explain certain functionalities of uh, the functions themselves, the variables, how things work in the interface. And what we're going to do a little differently this time is I'm going to give the starter code for everybody. So what we're going to do, we're going to do like a little contest, and it's going to be in partnership with Make School, of course. Um, and when I give you the starter code, you will take it, you'll build your own snowman, you'll submit to us through our Discord channel, which we will link, and we'll you send that in. We'll give about a week for everyone to give in their submissions. And next week on the show, we'll announce who is our winner and they will get their prize. So that's something we're decided to do differently, make things more interactive so people could practice a bit more using the things that we're creating rather than just, only just watching the show and then leaving and coming back later. We want to make it something where people can actually um, you know, practice the things that you're learning about on this show. So without too much further ado, I'm going to go ahead and switch to sharing my screen so that you can see what I'm seeing and we can start getting into things. So go ahead and pull that up right now so you can see that. Alrighty. So this is p5.js. Um, it is So what I've done on the show before is I use processing.py, which you'll see up here. And it's similar in the sense that it is a way for you to code things visually rather than always just, putting in code, getting code out. It's not always fun to do things that way. You want to just like kind of see the results of things that you type in. It makes it more real that way. So this is a library called P5JS and is built in the language JavaScript. JavaScript is a very popular coding language. It has been around for a very long time. It's often used for a lot of front end things like design of websites, of making animations, and as it even says here, creative coding and making it accessible. The beautiful thing about P5 is it's very lightweight. So if you want to download a copy of it, you can to your local computer and do it that way. For our purposes, we want to get right into things. So they do have a editor that you can pull up, and that would be over here. So you can see that like you can jump straight into things, have different files. So it's very easy to just get started with this library. As well as what I really like about it is it has very easy to read and straightforward documentation. So you can go down to reference and it gives you all sorts of functions that are already built in. So that's another good thing about this library, is that you don't have to make everything completely from scratch, but you get started very easily into creating something. So what we're gonna do is we're gonna make a snowman. So this is my finished version. Like I said, I'm gonna go show you my finished version. I'm kind of walk through the different things I use to build the snowman, and then move things around a bit, make some stuff bigger, different colors, sort of thing, just so you can kind of see how easy it is to interact with different objects. And then from there, I will share out the starter code, and that way, and as well as links to the reference, um, links to P5 page itself so you get on the editor and get things started. And then there's a quick note as well. We're going to use Replit for the starter code. It's very similar to P5 in the sense that it's an online editor, so you don't have to like download anything. You don't have to do any like heavy lifting. You just get straight into the actual code itself. And I try to put it in such a way that you don't have to too much worry about the heavy lifting of what's going on in the background. You can instead just get straight into coding of things yourself. So to give that, this is what I have created. This is my snowman. It's I think he's adorable. He's very straight to the point snowman, but I don't want to make it too complex for myself or for anyone who possibly wanted to get into this. So what we have here, we have different snowflakes falling in the background. You see that they're stopping and piling up on the bottom, so it can have a bit more of that realism to it. Because real snow doesn't just fall past the ground off the screen forever. So we want to build it up, have like a nice little aesthetic there. We have our 3-layered snowman with 2 arms sticking out. Now the arms, when you go into the code, you'll see that I made the arms separate. You'll see here there's a left arm and there's a right arm. You can make both arms the exact same if you wish. I just wanted to do them separately in case one is like this or like this or like something like that. And then we have the face, which has a mouth, a little carrot nose, 2 button eyes, and his little top hat up here. Um, so that's kind of like a quick rundown of this how things look visually. Now, what I'm gonna do before we go back into, I'm gonna explain these files over here. You shouldn't have to interact with them too much when I give you the starter code. You should just really only need to stay in the sketch.js. That's where a lot of what's going on is actually happening. I did leave the snow in, if you go to the snow.js over here, I did leave a lot of the snow in the starter code already. And that is simply because the functionality for the snow is a little more complex than the actual snowman himself. The uh, the snowman is just functions and squares and circles and lines. The snow itself has a lot more. It's animated, as well as it generates multiple at a time. They move positions. They're all sorts of different things. So I had built a class for snow, which has a lot of different methods inside of it. So I will explain it on a very basic sense, but I recommend that when you get the starter code to really just focus on the sketch itself and the snowman's body. But if you wish, feel free, want to get those extra style points to win the contest, you can definitely go into the snow and try to move things about, maybe have bigger snow, smaller snow, more snow, different color, it could be raining like gold snow or like green snow, I don't know. Things like that. And of course, if you have a bit more experience, you can always like alter things and as you wish. Then we have the index file, another file you shouldn't have to interact with, but I just want to point out that it's there. It's really just the layout of everything. It makes sure that it can read the other files. And so that if, say, later, you wanted to share this project out with people, put it like on a web page, then you would have the HTML already there. You just easily say, okay, here's a link to my snowman for people to see. But there's like really absolutely nothing in there you should have to touch. Similar with the style CSS is it's really just controlling like the box itself. If you wanted to put a border around it, make him look like he's in like a window frame or something, you would do that in here. But most likely you could just leave this as is unless you already have experience with CSS. But we're not going to touch that today. We're just going to stick to the JavaScript of it. So what I'm going to do, I'm going to go through the snow first, just because we're not actually going to change anything with this. I'm just going to break down kind of what it is and how like snow operates, because I think that's like, for me at least, it's probably the biggest challenge, but it's the most satisfying part to actually get working. So I'm going to go kind of line by line, more or less line by line of this, and try to, you know, tell what's happening in here, but I'm not going to change anything. I just want to lay it out in case anyone does want to say, you know, I want to alter this, then this will give like a decent foundation, and then you can go later as well on like documentation for P5, or just, you know, our good old friend Google, and alter it as you wish. So the snow itself as a class is basically, you could think of a class as like a template. Is going to set the basis for one thing that you can use over and over and over. So that's why we have so much snow in here. Is it's not saying, you know, I just want this one circle. Is you make a structure for one, and then you see like do it 100 times. So that's what this basically does. This constructor is just like, here are the base. If I was making like a template for a website, or like say I was making like a cupcake, I would make the base for the cupcake, how every one of their colors is going to look, what size they all are going to be, what frosting are going to be on all of them. That's what's happening in this constructor. Is I'm laying out the basis of, this is what every single one of these has to have. If I was building like a person, I have to have arms and legs. They might be different shapes, different colors, different sizes, but they all are going to have arms, legs, a brain, a heart, those sort of things. So that's what we're doing in here, just laying the framework. The X, the Y, these first three are really just like the positions of it. For JavaScript, you have to put let in front to say like this is going to be a variable. It's going to hold something else. For that, I would say look a little bit more into JavaScript itself to learn more about like how the variables are set up in JavaScript versus like Python, which is usually what I would code in on the show. And then you as well have this dot position, basically sets up a different type of variable for the position where this item is going to be located. And we have create vector, which, let's hop over real quick to the reference so we can see how how to look something up in the reference, as well as kind of what it says for us. So if we go to the reference side of things, we can go into the search bar and say, in this case, we're looking for create vector. We know exactly what we're looking for right now, so we can type it straight in. Pull it there, pull it up. And it gives you how it's going to be. It gives you a nice example. And it tells you like a description. It creates a vector, like data points. So X, Y, Z, coordinate system, you know. You don't have to use all three, and it tells you what it returns. So this is a really good way of just finding out more information about that. So to go back to the code, we have that vector X and Y because, of course, working in a box, so we have to have like X position, Y position. You know, the good old coordinate plane system we learned about like eons and eons ago. So then we have the speed as well. And I think speed is explanatory. You know, how fast or how slow are we going to move? I'll alter that on the other side when we get there, just so you can see how that may change. But in this case, we're saying we want it to be between like 0.5 and 1.5 speed. So say if I change like this 1.5 here and put like a 3, this snow should fall very fast. Yes, very fast. It does not look like realistic snow, but it would be a good thing if I was like making rain. But we're not making rain. Or maybe if it was hailing, maybe you can have yours like that. Instead of it snowing, you're like, this is just like an extremely crazy blizzard and it's hailing. So you could always do that too. Or you can make it slower, make, lower number here, lower number here. But the reason it's random between these two is, say, all of the snow is falling at the exact same rate. Then it looks like someone would just have like a curtain pulling down over him. And I mean, technically, in real life, everything moves at like gravity speed, but because of the acceleration and all these other things that are happening in physics with how things fall, they may fall at different rates. And that gives it a little more realism to it. So that's why we wanted to have a range. We don't want every single flake of snow falling at the same exact range. Okay. The size, similar thing to what I just explained. We have a random between 2 and 10. Every snowflake is different. We don't want all of our snow to be the exact same size. You can. The reason that I didn't was because, actually, I'll show you real quick. We'll just do this, and we'll say all of our snow is going to be a size 2. Can't forget the semicolon. So it looks like this. It's still snow. It still looks like snow. But the thing that, for me, why I put a range of sizes is because in real life, things that are larger are usually seen closer, and things that are smaller are usually seen further. So because we're not trying to work too much with like an actual distance variable, in this case like a z, to simplify it, we can make the illusion that like we can trick our brain into thinking things are closer or further. And by doing that, we can just alter how big stuff looks. So right now it just looks like it's just falling straight down. The speed kind of makes it look a little more in depth, but by changing the size, it's like, oh, the bigger ones, they must be closer. It must be in front of the snowman, or the little ones are further back from the snowman. So this is what we're trying to get the illusion of with that. And then the max size down here is to put the snow at the bottom. Since like I said, we don't want it to just keep falling off the page or to stop at the bottom. We say we want it to stop somewhere between -60 height. This is our height. This from top to bottom. So our maximum height is right here on the X. It's really weird at times. I know in like a normal coordinate system, the higher you go, the bigger the number. But because in P5 your 0, 0 is over here, then your biggest X is over on this side. It's going to go larger the more right you go. And your biggest Y will be at the bottom. It's going to get larger as you move down. So that's something to keep in mind as well. It might be something just to practice with. Just, make a dot on the screen, make the numbers bigger, see where it moves. That kind of helps to keep track of those sort of things. So yeah, in this case, -60, you want to go back this way, so around here, from the looks of it, through the height. And so that way they're all stopping at different points to, once again, make the illusion that there is a floor. All right, and so to continue on, so we have these here. You notice they have parentheses after them. Anything with the parentheses after it in a class, or really in JavaScript in general, like this, says it's a function or method. This is a noun. Well, not a noun, a verb. This is something that is actually going to do, so we can call on it and it can tell the snow, like, now that it's created, what are we going to do? I see a question of how could we make a wind effect for the snow? You would change the horizontal position. From just off the top of my mind, I personally never made it. Make wind, but I would say you would change the X position. So I could say as you're falling, I can make a horizontal speed or a wind speed and say that let me see on line 0. Yeah, so we already have that speed actually here in our X. But I set it to 0 so it goes straight down. Let's say we put like a 2 in there. See what happens. It's all experimentation. Oh, boom. It gets a little wonky because it's trying to fall. It's the starting points where the starting point is starting up here. The snow is actually sitting like right here. the illusion that it's falling, but it's starting about here. And so since it's right here, when it's falling, let's say the most left one is right here in the background where you can't see it. It's falling down, but it's going over. So it's going like this. Now, if I had like the snow somehow starting like way back here too, and it went across, then we get more down here. But we don't have it set up that way. And so that's why we have this effect of it only filling up part of the screen. But you could also change that by, you know, up here in your X, you can have it set to how, so for the Y, the reason it's starting up here is because I told it to start higher up on the screen than it actually should be. Same with the X, we could say like negative 200 or something, and it would start over here. So it's all about trial and error, customization. It's kind of seeing, that's like the good thing about visual coding that I like better at times than just regular hard coding things, is when you're hard coding things. Oh, I made that wrong. Take that back, so it's falling straight down. Cool. So the thing that I like about visual coding versus regular get your output type coding is it's easier to quickly try things out because you can see it. If I'm just getting numbers out or if I'm getting errors out, then it's like, oh my god, what's going on? But if I see the results of it kind of solidifies it. It's like that visual learner versus a tactile learner versus auditory. I think coding as a whole is more tactile because you're like using your hands in a sense to make something happen. But when you're doing visual coding, not only are you physically using your hands to make something happen, but you can see the results of it immediately. And your brain is like, oh, picture. I can understand this picture rather than like this long string of random numbers that I didn't have to further figure out what that even means. So that's the benefit to that. So the draw function down here, this is just putting it out on the screen. It's actually going to make my snowflakes for me. It's pretty straightforward, and this is really the basis. Later when we go into like the snowman, this is how we draw things over there as well. So in this case, we're saying we'll go from the bottom up to explain things, but in JavaScript, it does read top down. So it's going to look at the fill, which is like what color, the stroke, which is like the outside border of the shape, and the circle is the actual like shape that we want. So if we went into circle, you see we have this X, this Y, and this size. So what I'm gonna do, I'm gonna hop back over to the reference and go back. So another way to search stuff in reference rather than just saying circle, because I'm sure oftentimes, if you're really just getting into this, you're not going to just off the top of your head, no, here's the name of the function. Let me search it up. So instead you'll come here, you can browse through. So I want a shape. So that shape here. So we got plenty of shapes. Some are easier to use than others, like a quad. I don't think I've ever used a quad. And like ellipticals. There's like a Pac-Man looking shape that we'll get into. But let's say we want to just make a circle. Pull here, boom, circle. And it shows you a simple circle here. Draw location 30, 30, diameter 20. So if you were to make the circle, say this is your X position, your Y position. Your positions are going to be the center of the circle. That's something to keep in mind, is whatever position you say is going to put the center of the circle at that position. So remember that. And then you have 20, which is your diameter of your circle, just how big it is in pixels. So, and it says that as well down here. So if we go back to our version, we have our X position. We see this dot position dot X. This is just saying, look for the X position from what I gave you up here. Similar for the Y, look for the Y position from the data I gave you up here. And the size, of course, is the size from up here. The beauty of these type of functions is they can be called multiple times, so I don't have to like write, I don't know how many snowmen are over there, how many snowflakes, like a couple hundred. I don't have to write like 100 to 500,000 times every time I want to make a new snowflake. So this sets that basis. Every single snowflake is going to be a circle, and it'll read those values to get the actual dimensions of it. The stroke, like I said, is like the border, the outside of it. So I just put 255, which means white. In RBG, that's usually what it'll take. There's other ways you can use if you like hex code colors. Um, there's plenty of others that I suddenly have forgotten. But you can use, I usually stick with RGB. It's just the most straightforward to understand. So if I put like stroke 0, I believe this will turn the outline black. And that is some terrifying snow. So we are going to turn that back to 255. But say you want like a cool color, like a red snow, we could say put our R at max 255, put green at 0, and blue at 0. And we have red snow, which is also terrifying. So we're going to get rid of that once again. Don't want. I would be a little concerned if I walk outside and it was red snow falling from the sky. But I mean, it's 2021. Who knows? That would be interesting. If it was like strawberry flavored, though, that'd be nice. And so similar here with our fill, it's just like the inside color. For this, I put them all to be white, but this value here at the end, I could just have put 255 and called it a day, just like I did with the stroke. But I wanted it to be like just the slightest bit transparent. So there's an extra variable at the end. It's called alpha, and it's, if you thought of it in like terms of like Photoshop or Microsoft Word or any editor like that, this would be like your opacity. So you can alter that to get it either be more or less see-through. So I put it at 100. I just played with that number until I got like it be semi, just barely transparent enough in there to make it like snow-like and not like hail falling from the sky. And then lastly, for the snow function or snowflake that we're making is this fall function. This is actually making it move. The rest of it, it'll make them and it'll just put them in places, but it won't actually do anything. So this function is like, okay, now I actually want you to like fall out of the cloud way up there in the abyss. Otherwise, if I didn't call this fall, it would just sit up there by itself. And I'll illustrate that later. My computer does not like stuff. I'll illustrate that later. So for the fall, if we look in here, we have an if statement. And this if statement says, basically, if you get rid of all this dot position, this dot, blah, 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 we're looking at if our y value is less than or equal to the maximum size, which again is up here. So if our y value is not at the bottom of the screen, which it shouldn't be, we're starting at the top. So basically, from the moment we start till it actually hits this bottom, so all of this in between, we want to get the position and add to it. This is another built-in function you can look up in the reference. We want to add the speed. So if we're up here and we're at position 0 and we want to like move down the screen, then every time this if statement goes until we get the bottoms of it, +1, +1, +1. And that's how it's going to look like it's moving down the screen. So that's why I pick such small numbers. The bigger the numbers for your speed, the faster it's going to move, because it's just going to keep adding bigger and bigger numbers to it. So that's really kind of a quick explanation of how we get snow in this case. And like I said, with the starter code, I left all of the functionality here for the actual snowflakes. That way, I know that jumping into classes can be really hard. I myself first learned code in, I think it was Python, oddly enough, and now that's like my thing. But when I first learned code, it was Python, and I was like, oh, this makes sense. This makes sense. And then we started learning about classes, and I was like, I hate code. I don't understand anything anymore. What are you talking about? I couldn't comprehend. Also, because I was doing C, I highly don't suggest C. this moment anyway. But we'll get into that later. We'll do some robotic-y stuff. We might touch on some C. So I left all of this here. So if you want to, when you get into the starter code, let me show you where that is. If you went to the repel that was shared and go to the Snow.js, all of that is here. So if you want to, you do have the ability to go in there and change your colors, or your snow, your speed, your sizes, where it starts, how it blows in the wind, um, how big your ground is. Maybe you know have your snow fall to the ground, and when it gets to that final position, it changes color and it like magically turns from snow into grass. It's possible. We are not going to attempt it right now on live, right? But you can do it. I would love to see it. And and um, and then before we go into the rest of this code, if you look in the chat, we updated the link to the starter code. This was a bit easier to access. So you can still go to that link and everything should be good for you to just get off your feet started. Uh, so yes, thank you for that. And so if we go into the sketch.js, think of that as like the main important part of this. That's really what we're doing the heavy lifting in. Um, if you have any experience with Arduino, with processing, with P5, I'm sure there's plenty of others that are set up in this way that this is set up. But if you look at, let's say, like a blank one, this is what you get when you start like a brand new P5. It gives you a function, the setup, and a function draw. And that's to say the setup is, this is what we need to just have anything happen first. It's like initiating. That's what this is. Setup is your initiating things. And then draw is like, okay, now do it. Do the thing. Make it work. So in ours, we left our setup as the same. Create a canvas 400, 400. Now, I'm not sure how it would change things. It would probably break a lot of things if I changed the canvas size right now. I'm gonna change it, but it's gonna break it probably. Everything's not gonna scale properly because everything isn't based solely off like the height and the width is based off like the actual 400 and 400 numbers I put in. But let's say I put like 600 by 600 in here, then our box should get bigger. So our box went to size 600, 600. And you see that on the upside, we have a bigger space. On the downside, the snowman has transformed into something else entirely. We're going to put that right back to where it needs to be. So, and there's a quick note. I put this snow equals empty brackets. That's an array, also known as a list. What it does is when it creates snowman, it puts them inside of that list. So if I were to print out snow at the end of this every time, actually I'll put it, maybe it'll work. If I remember how to print in here. I don't know if this will actually work out. Okay, well, we're not going to fix this. Basically, what's happening is every time it runs and it makes a snowflake, it's putting it inside of this snow list. So you see it started with like just a few snowflakes. And then as it goes through, it's making more and more and more and more until it's just infinite. Actually, it is infinite. There's nothing in here to tell it to stop. And I know I mentioned like in our last show we were talking about fractals and recursion and things will keep going and going until they break. I'm pretty sure if I let this go and I had enough computing power and just let this keep going, it would break something. But luckily, I'm not gonna let it run that long, nor do I think it'll let it do it. It'll just slow down my computer significantly, so we're not gonna try that. But in most cases, you wouldn't want any sort of infinite loops because they do tend to get literally out of hand. So So we got our draw function here. So this is what it's looking at. This is literally the only thing it's going to look at when it comes time for it to run. I do have other functions down here that I'll go into, and those are the ones that I would have you build out to make your snowman. But it doesn't actually go and be like, I'm gonna now run this, I'm gonna run this. It doesn't go through every single and just automatically do the other functions. It's only gonna look inside setup to get started, inside draw to actually run the code. If I didn't say in here, for instance, here's our snowman. If I have this snowman function here that draws like the body of the snowman, and I call it up here the snowman. If I got rid of that, I was just like, it's like, don't even look at it. It would not draw his body. He's just floating. Because even though it is coded down here, I didn't tell it to actually, in the draw function, I didn't actually tell it to draw it. It's like having like a sketch of like a picture that you say you wanted to like practice drawing something before you painted it. If I have the sketch of it that I drew out and then I never was like, go paint it, then it's never gonna get painted. Or if like I wrote an email as a draft, it's still there as an email, as a draft, but if I don't send it, it's never gonna go anywhere. So that's really what's happening in this draw function is actually the one that's sending the data, but you have to specifically tell it what to send and to not send. Let me get rid of that because I'm concerned. So to go through this as well, so we have a background similar again to the fill function, to the stroke function. The background creates our color scheme. So let's say we put 135, 255, more red. We would get like a pink background. That's cute. I might keep that. No, we'll put it back. We'll put it back. But it would be really cool to see like someone could make like a cotton candy background, snowman, something. That'd be cute. And again, the alpha to make it like a lighter shade. What I personally do with this, in the beginning, I would just play with the numbers until I got the right shade. And then I realized there are tools that can do it for me. So I will go to like Google and look up RBG color picker or something like that. And it'll give me like an interactive block. Just like you can in most editing software where you can just like move the cursor around and it'll give you the actual numbers of the colors. I just went there and like moved it around until I found the right shade of blue I wanted, and then just like import or copied and pasted in the numbers I wanted. You always got to find a way to make your life easier in coding. Otherwise, you just every day. So then the next thing, this snow.push new snow. This is going to call from our snow function. So this is not something I would, this and this for loop here, I would not recommend probably messing with when you're actually doing your coding. Really there shouldn't be much editing of what's in here because you do still want your snow to fall. You still want your snowman to actually build, your arms to come out, your face to come out, your hat. You can add more. Say you want to give him like a tie. You could put like a tie function in here and then build it out down in the bottom. But I would not suggest really changing or messing too much with this part of the code because you do need it to actually get things going. It's your engine. If you can edit parts of the car, but if your engine's broken, you're not going anywhere. So what it does basically is it's going to look at the snow class. It's going to say, I want a new snowflake. It'll look at, the other file for your snow, do all the things in there to like create the snow. And then it's going to push it into that snow array that we have at the top. And that's all at the bottom when you're printing. It's like every time it went through, there's a new snowflake. You made a new snowflake every time. The draw function would just keep going. So be careful about what you put in there because like I said, it's infinite. It's just going to keep going. So if I told something to like push 10 snowflakes every time, then it just would get out of hand very quickly because it's just going to keep every time making 10 snowflakes at a time. So we're just going to do one at a time here. The for loop is what is being called to you know, when we're in the snow function here, we had fall and draw. So what this does, it says for every flake of snow, we are going to tell it to fall and to draw a new one. That's what it does. It just tells this overall draw function to actually make a snowflake and draw it and make it fall. Doesn't matter what order these are in, but I put fall then draw just because that's what it worked out for me. And then we have your left arm, your right arm, your face, and your hat. Like I said, those are just there so that they actually get drawn. If I, once again took off that, then he'd have no face. So those are necessary. Um, and then just to get into these real quickly, so this is really where the documentation comes in heavily. You will see I have some math in here. I don't be alarmed. It's fine. It's just division, multiplication, a little addition in there somewhere. But nothing too heavy. It's just more so like where do I want things to move without me having to actually like go find the number. I could have just put like, right here, height divided by 2. I know my height is 400. I could just have said 200 and nothing would change. But just for me and my own readability, I like to sometimes explain it out like in actual words rather than just like numbers everywhere. And it helps as well because in these cases, say, earlier when I changed the size of the box and made everything big, some stuff still worked because I told it, base what you're going to be sized as, base it off the actual width and the height that I set up here in the canvas. But other times I told it, go to draw these exact positions. And so if the box got bigger, but where I put it didn't, of course, things are not going to go where they need to go. So it helps in that case just for like scaling, for readability, help keep you a little sane, in my opinion. And then it's a little less work trying to be like, okay, I needed it this 282, not 272. So less trial and error, I think, when you do it that way. But for the snowman, so his body, pretty simple. He's 3 circles stacked on top of each other. Doesn't get too much more simple than that. So I told it no stroke. I don't want an outline to him. I could say again 0, and it'll look like he got drawn. Oh no, not that part. No stroke would get rid of it. I'd have to say like computer stroke 0. No stroke just says don't put any line there at all. No border. So if I set the stroke to 0 or any other color, then it would create that, and maybe that might work. Give you like that cartoony holiday card look. But I wouldn't mind to not have any. So instead, I put no stroke, and that way it has no border. Boom, boom. So then we have our fill down here, set to 255 because it's a snowman. We want him to be a white snowman made of snow. So no fill to this guy. If I was making like a rock monster or something, maybe I would be gray or brown. I don't know. So that's something. And make sure you put the colors and the stroke above what's actually getting drawn. Like I said, it reads it top down. So if I put them after, then there would be everything would just be default, and it would not draw anything or give it any colors or strokes. It would draw the circles first and then like, oh, now we color it, but there's nothing to color because it's already drawn. So it's like, what did you want me to do? So make sure those will go first so you can actually edit, and that'll be illustrated a little more at the bottom as well. We show like the nose. And then we have 3 circles. Our first circle, this is our position, 200, which is like smack in the middle. Then we have 223 325, which puts it here. This is like 325 height, because remember, it's the center of the circle. And then 150 is diameter, so he's like, you know, heavier in the bottom than he is at the top. Makes sense. He's a snowman. There are circle above. So this, because of these numbers, I just kind of played with these numbers, so I got it kind of positioned where I wanted them to. So the next one, we still want it in the center of it, so it's stacked up on top of each other. 220, which is a circle right about here, and 100 diameter. So it's a little smaller than the one above. And the same thing again for his head. Put it in the middle, put him like right about here, and a smaller circle. And that's how you get your snowman, the base of your snowman. So you could, if you want, you can make a different shape. You can make him out of squares. You can make him out of triangles. You could make him have a border. You can move him to different sides of the screen. If I put, I'm gonna move him, even though the rest of his face and hat and such will not move with him if I do this. But just to illustrate, if I did 300 and he scoots over that way. So if I did something like that, of course, then I'd have to move everything else with him. But, you know, that's just to show that, like, he doesn't have to be in the middle of your screen. You can put him in the foreground. You can make him smaller so he looks like he's in the background. Complete creative freedom. Because the beauty of code is it gives you the ability to literally create whatever you want. There's like a saying that truly advanced technology is indistinguishable from magic or something along that line. And that's what it feels like. I feel like coding, you become like a wizard, like a modern day wizard, because you literally start off with like this that does nothing and shows nothing. I think like if I ran this, just a gray box does nothing. But once I like start learning the tools and like how things work and the like the magic spells that are the lines of code to chant out, then I get a snowman. It's really cool. So for the left arm and right arm, like I said, if you want, you can put them both together and just have one arm function that draws, like, it just combines all of this into one and then just call one arm. But I put them separate just because they're on different parts of the body, and I was going to try to do this weird fractal arm branching situation that did not end up happening because fractals can be complicated. And keeping it very low scale would have been a little crazy. So to go through this, since they're the same, I'll just explain this one. For this, I put a length up here as a parameter. That's why we have 100 up here. That's the length. So they both should be about 100 pixels long. If I change that 100 value, where are we at? If I change that 100 value up top to like 300, you have like super long arms and tip over. Well, maybe not. Branches aren't that heavy. But in real life, he looked pretty crazy. So what it does, of course, we have our stroke. So like what color do we want it to be? So I tried to pick a nice brownish color. And then I put a weight of 3. Well, I could put, the stroke weight is how thick you want the line. You could put that anywhere there's a line. So I could have put up here with this stroke as well to make like the border. If I put a border on the snowman, I can make it heavier there. So they say I put like a 9 stroke. Beefed up quite a bit. So where if you want to, my snowman has regular twig arms, but you can make your arms however you like. And then our line. So once again, let's hop over to line really quickly. Put that in. And for a line, you see it's 4 parameters. If we look at the syntax, x1, y1, x2, y2. So we need basically the location, the coordinate of where we're starting, and the coordinate of where the line stops. So here, our starting x is the width times 0.4. So a fourth of the width, which is like here. That's like, you know, if you broke this into 4 pieces. And our height is divided by 2. So it will be in the middle. So like, yeah, right about here, smack halfway. Then the stopping point is the length. So 100. So basically I want my x to go over 100 points. So from where it started here, go 100 points that way. Remember, it's adding. If it gets bigger, it's going to the right. I had to start here, draw across. And the height stays the same at divided by 2. So we get a straight across line. If I said like height over 2 plus 20, I'm gonna leave it like that. So it's cool. So yeah, you can make them, arms up, arms down, wiggle around, all the good stuff. And then the same thing with the right arm. I just have different starting points because it's on the right. So same color, same weight, but the line instead is at 0.6. So instead of starting over here, it's starting over here. And same height, because we have even arms. And then what I did, similar to how I just added 20 to the length, I said I wanted to go start it here at the length, which was 100, so go across. And then I made it a little bit shorter than the other one because it was just like being funky. So I just played with some numbers to get it to be right. Which is sometimes something you have to do. You just kind of have to just throw stuff in there, see what happens. Because there's definitely times where I was like, oh, this thing will work 100%. I can just copy, paste, add on a couple numbers, boom. And then everything breaks. And the arm is like 3 times longer than expected. So I just kind of played with the numbers until I got that set up right. And I'm going to go through this really quickly because I know we're getting close to time. So our face and our hat. Just I'll point out a few important things that are a little different about this rather than going exactly line by line because a lot of this is the same as the other ones. So in the face, we have eyes, which are these 2 circles. We have, similar to before, X position, Y position, diameter, and fill them in with black. Then the nose is a triangle. Triangles are a little more complicated. They're more complicated, not a little bit, they're more complicated. And that's because you have to have the position for each corner of the triangle. So that's why there's 6 in here. We have, this is our first corner. This is our second, oh no, this is our second corner. And this is our third corner. So that, I'm just going to explain how I found those numbers because it took a solid like 20 minutes to just figure out like, no, go this way, no, go this way, and no, go this way. It took forever. So that's something you have to play with again to find out how you want your triangle to be, where you want it to be, the shape. And then arc, I'll pull that up really quick because that's a little different. That's my Pac-Man shape, as I call it, because you can do really cool stuff with this. Like this shape, my Pac-Man shape. So I did like this one down here. This one could be a little bit more complex because you have to utilize like pi and to get like the roundness and the chopping of it. I just suggest looking into documentation heavy on this one and trial and error to see what shape you get. But ultimately, I got this little half full moon shape here for his mouth and rotated it so it was up, so he had a smile. And that was just all this arc, pi, that. So that one, I was looking to documentation again to do that, but you can also make it a circle, and you can make it like a straight line, have him be like a little bit more deadpan. You could put a heart. I'm not sure how you would make a heart. I think a heart would probably be a little complicated, but if you do it, that's some strong points. And then lastly, we have his hat. You see, we got a stroke of 0, stroke weight 5. I wanted to have a little thicker brim line down here, so it's 5 stroke. The line, start here and then move to here, like you're drawing a pencil across. Fill 0, make it black, and for this we have a rectangle. Let's look one quick at the rectangle. They're not usually too bad. There's different ways to draw rectangles. in this case, they give it like the location and the width and the height. So I gave it, this is its location. And then because I want it to be a perfect square, 40 by 40. And then the 7 here is to round the edges. You don't have to have that. If you don't, it's just like boom, boom, boom. But my 7 is more like over and then like curve a little, like curve a little, just to give them like a little schmancy fanciness to that. Um, yeah, so that really covers everything in terms of my snowman. Like I said, like we saw a few different things of like how to alter the code, how to change color, size, shape, position, which are really the important things of what you want to do. You'd be amazed at how much you can really do just by changing those few things, as I'm sure we saw about here. So I would suggest to, use this article, experiment a bit. If you look at what I have in it for your sketch, like I said, the snow is all there. The main draw function is still here. The arms are empty, so you can change the length of them if you want. But if you look down here, the actual functions, they're all empty. So that way you have full ability to just say, okay, for the body, I want a square, the arms, I want some triangles, the face, I want to be like upside down moon shape. The hat could be like, you don't even have to have a hat, it could be hair for all you know. So you can start, and it should be really easy just to jump into it that way. Get started, and then as well, um, I will put really quick in this chat the link. I'll put it in the Twitch chat. p5.org/reference. That leads you to the main reference page here. Then of course everything's there. You have your editor. If you ever want to work directly with the P5 editor rather than the Repel that I gave you, you could just click editor. When you get started, that gives you other instructions for how to get started on your local computer or in the editor. You can always donate to the developers of P5. Look at different libraries. There's tutorials and examples. There's tons of stuff out there to get you started. So that about wraps up our snowman tutorial. Just a reminder that the contest will be running until the end of the month of January. And we're going to post the rules on the Discord channel. So you can go there and we'll have it laid out exactly what the rules are, what we're looking for from you, and what to expect for us. There also will be multiple prizes. But the details of that also will be inside of the Discord channel, so I would suggest looking there. So what I personally recommend, of course, get the code, get started, have a little fun. Should be accessible for anyone on any computer as long as you have internet. Then you can just pull up the Repel notebook and just jump straight into it. And then you can either send a link to yours so we can run it ourselves and see, or you can send like a screenshot of say you don't want you don't have like the code animated, you just have like the snow there. You can send a screenshot to us of that. You can send us the code and we can run the code and see what we get. And yeah, so once again, I want to thank you all for coming. I'm just going to drop in the chat if you want to further connect with me. Anywhere you can reach out to me or follow me on Instagram. That way you can get more updates about when I have the show, or any just if you want to learn anything about code, tech, science, crazy thoughts that pop up in my mind, you can follow me there and get more about that. Also, you can go to the Discord and get more interactivity with Make School as a whole. You can reach me there, as well as meeting other students, seeing other shows. There actually is a show right after mine with Brian on Tech Topicals. And so if you stay tuned, you're able to go see his show, reach out with him, and generally learn to become a stronger tech person at the end of the day. So I would like to wish you all a good rest of your week. Good luck in the contest, and I will see you next week. Bye.